Okay, so I'm going to work through the first few problems on practice exam A. The first problem tells us that we've got the wait time at the BMV, which is uniformly distributed, and it goes from 0 to 60. Because the minimum here is 0, it makes this problem a little bit easier, but I'll kind of walk through. It doesn't matter what that minimum is. We can, solve these questions in a similar way. So for the very first one, right, we've got the mean, and then for the second, it's the variance. Now, if I was approaching this group of 4 problem, which are all referencing kind of that uniformly distributed variable, I would draw out what my uniform distribution looks like. So we said it started at 0, ended at 60. So that's my minimum and maximum, or what we kind of notate in some of those formulas as point C and point D. We know the height of that distribution will always be 1 over whatever that range of values is. So 1 over the maximum minus the minimum, 1 over D minus C, in our case, 1 over 60 minus 0, giving us that height of 1 over 60. Now, for the mean and the variance, I've kind of got the numbers plugged in here because I'm having some issues with my camera today. Nope. So let me show you. On our formula sheet, we've got our uniformly distributed formulas right here. Okay. So 1 over D minus C gave us the height of the distribution. The mean will be add up the maximum and the minimum and divide by 2, or you're kind of looking for that midpoint between the maximum and the minimum. And then our variance excuse me, is the maximum minus the minimum squared divided by 12. Okay, so the mean and the variance of a uniformly distributed variable always follow these two formulas. So we're just going to go ahead and plug our values in. Right. So we've got the mean will be the maximum plus the minimum. So 60 plus 0 divided by 2, which gives us that mean of 30. Notice for a uniformly distributed variable, it will also be symmetric. So the mean will also be the median. So essentially that mean is just going to be the midpoint of this distribution. So you're just looking for that middle value in between the minimum and maximum, which means you just take the average of the two, add them up, and divide by 2. So that one's easy enough. The second one, the variance, we're going to look at the range of our uniformly distributed variable. So that variance is sigma squared. So here, 60 minus 0 is our range. We square that value, then divide by 12. That's what the formula told us. And we get an answer of 300. Okay. Now, the only other thing I could potentially ask you on the exam here is maybe I only ask you for the standard deviation, which that simply becomes you just take the square root of the variance here. Okay. So that's problems 1 and 2. If I then go back, not to the formula sheet, but to the actual practice exam, what's the probability somebody waits more than 30 minutes? Okay, so I'm going to do this kind of problem in red. So we've got, what's the probability you wait more than 35 minutes? Well, thinking here, I said, actually, I'll draw where the mean would be at first, just to kind of give us some context and point some things out. So we had a mean of 30. So what we know is true about a symmetric distribution is the mean exactly splits it in half. So there should be 0.5 to the right and 0.5 to the left of that mean. The problem asks us for what's the probability that we see something above 30? Double check that. I think that's what it said. All right. So we're looking for this area here. Okay. So right away, I know that the probability that I'm looking for has to be less than 0.5 because the area to the right of 30 or the right of the mean is 0.5. I want something that's kind of smaller than that. So if I'm looking here, yeah, and this is more than 30. Right. So we wanted the right-hand side there. So I could rule out anything that's greater than 0.5. This one, I don't even have to do the work. I can rule out B, C, and D. I automatically know the answer is going to be A. Now, just in case I don't give you an example on the exam where you can rule everything out, let's take a look and see how we would kind of find that area. So here's the probability that I'm in between two values. Okay. So if I wanted the probability I'm greater than 35, I could plug in the minimum and the maximum of the range I'm looking at, and then divide it by the range of possible values for that uniformly distributed variable. So D and C were our maximum and our minimum. B and A would just be where our interval starts and stops. So if we're looking here, right, my interval kind of starts and stops at 35 and 60. So what I could do is plug in, right, B minus A to that formula, divided by the range of possible values, 60 minus 0. Now, I usually tell people to approach it in a slightly different way because I think it just makes a little bit more sense. So here I've got what, 25 over 60, that ends up being that 0.41 approximately. What I could have also thought about is, well, I'm really just looking for the area of a rectangle here. So I could have said, okay, what's the width of my rectangle? That's just 60 minus 35. And then I could have multiplied it by the height, which we said earlier is just 1 over 60. And if I do that, I'll get the exact same thing that I did by kind of using that more technical formula, I guess. Okay. Number 4, I believe we're asked for the probability. It's between 15 and 20. Okay. So once again, I'm just looking for the probability. I'm between two values, 15 and 20. So I'll do this one in green so we can kind of line up everything with. So I want the probability that I'm in between 15 and 20. Once again, I know that probability has to be less than 0.5. I think in that one, though, there wasn't anything we could rule out. And so once again, it's just the width of our rectangle, 20 minus 15. The height of our rectangle is going to be 1 over 60. So we've got what, 5 over 60 here. I think that is 0.08 approximately. I look at kind of doing this without a calculator for the time being. Yeah, I believe that will be that 0.0833. Okay. So actually, I'm going to go back. I thought I was sharing, it didn't. So that would be that 0.0833. Now, one thing I could ask that's slightly different on the upcoming exam would be, what if I asked you for the probability between 15 and 20, and let's say 30 and 35. Right? So I want the probability I'm in this range or in this range. Well, if I notice, they both have the same width, 30 to 35, 15 and 20, they both have a width of 5. They're going to have the exact same height. So the probability in between 15 and 20 should be the exact same as the probability in between 30 and 35. I think this was 0.0833. So I would basically just take this and multiply it by 2 or add it to itself. Right? So if I give you intervals of the same length for a uniformly distributed variable, we know those should have the same probability. The probability of seeing the x value take on a value in those ranges should be the same. Intervals of the same length should have the same probability. So those are the first 4 problems on that practice exam.